Welcome to this video on the quotient rule of exponents, positive exponents only. Let's begin. The quotient rule of exponents states that a to the m power divided by a to the n power is a to the m minus n power. Let's demonstrate this rule using x to the fifth divided by x squared. So remember that I can rewrite x to the fifth as x times x times x times x times x. And I can rewrite x squared as x times x. So now, you might notice that what I can do is that I can cancel out two sets of x's. So what is left over in the numerator? Well, what's left over is x times x times x, or x to the third power. Notice that we could have achieved the same result by simply subtracting 2 from 5. 5 minus 2 is 3. So this is a demonstration of the quotient rule. So let's start with this first example. We have a to the fourth power divided by a to the third power. So again, I could take the long way around and I could rewrite this as multiplication. And then I could see that 1, 2, 3 sets of a's cancel out, leaving us with only a single a left, meaning that it's a to the first power or just a. Or, again, I could take the shortcut and just do 4 minus 3. 4 minus 3 is 1, so we can just write a to the first power, or more simply, we can just write a. Let's do the next example. We have 2 to the 10th power divided by 2 to the 4th power. This time, we're not going to write it out. We're going to just apply the quotient rule. So the quotient rule says when we're dividing two terms with the same base, we can subtract their exponents. So 10 minus 4 is 6, so we have 2 to the 6th power. However, because we have a 2 as our base, an actual number that we can evaluate, we have to evaluate 2 to the 6th power, and that's going to give us 64. All right, let's do another one. Again, we have numbers, so we're going to evaluate them. But first, we are going to subtract the exponents. So we have 7 minus 5. 7 minus 5 is 2, and 2 squared is 4. So remember, a good strategy in these videos is to pause them, try to do the problem on your own, and then unpause it to see if you are correct. So this time, we have both variables and numbers. So let's start with the part of this that is just 5 over 10. In fact, if you wanted to, you could rewrite this as 5 over 10 times a to the third divided by a times b to the fifth divided by b to the third times c squared over c. And then you could think of it as sort of just a bunch of mini problems all strung together in a single problem. Now, in the case of the variables, right, in case of a, b, and c, what are we going to do with those variables? Again, I'm ignoring 5 over 10 for now. I'm just going to let him sit there for a second. Right? Well, I'm going to apply the quotient rule here, right? So for example, here I have 3 minus 1 because I'm subtracting my exponents. So I have a to the 3 minus 1, which is a squared. Likewise, we have b to the 5 minus 3 power, which is b squared. And then we have c to the 2 minus 1 power, which is c to the first power, or just c. So with all of that subtraction, what happens to students a lot of times is they start wanting to subtract 5 minus 10. That's what they want to do, and then they want to put a 5 here. However, I strongly urge you, don't forget what you used to know just because you're learning something new. Math doesn't change its rules, right? It builds on itself. So everything that you already know about math is still true. In other words, 5 divided by 10 is still division. It is not going to magically transform into subtraction. Okay, I promise at some point in this section, you're probably going to be tempted to write a 5 here. Okay, but don't put a 5 there, right? So think way back, right, when we were just doing order of operations with integers, right? What did we learn? We learned that 5 over 10 is a fraction which we can reduce. 5 goes into both 5 and 10, so we can reduce it to 1/2. So that is what we're going to do here, right? So 5 over 10 becomes 1 over 2. So I can write my final answer as a squared b squared c all over 2. This is a valid way to write it. If you would prefer, you could also write it as 1/2 a squared b squared c. That's also a valid way to write your answer. So either of those would be correct and get you full points on any assignment. All right, let's do another example. Again, try pausing this video, seeing if you can do it without help, and then unpause it to check your work. So again, in this example, we have a fraction, right? We have 6 over 3, okay? And then we have n squared divided by itself, and then we have m cubed with nothing downstairs. Okay, so this time, let's do it differently. Let's actually start with a fraction. Again, before you met me, you probably knew that 6 divided by 3 was 2. Okay, don't forget stuff you already know. All right, well, what about n squared divided by n squared? Well, there's two ways to look at it. One way to think about it is that we have 2 minus 2, right? Or we would have n to the 0 power. That's one way to think about it, right? Another way to think about it is that you have something divided by itself. Well, something divided by itself is just 1. So n to the 0 power, and we're going to prove this more formally in a minute in the next video, okay? But n to the 0 power is just 1, okay? And again, if you don't believe me, right, if you think about n squared divided by n squared, well, it's really just n times n divided by n times n, and everything cancels out. So you're left with not 0, but 1. Okay, so we have 2 times 1 times m to the third power, so we have 2m to the third power. So that would be our final answer. All right, let's do another problem. So this time I have negative 2 over 4 times x squared divided by x times y to the fourth divided by y. So again, right, we have a fraction. We have negative 2 over 4, and this fraction can and must be reduced. 2 goes into both the top and the bottom, so we end up with negative 1 over 2. I also want to remind you about signs, right? Negative 1/2 is the same as 1 over negative 2, right? And it's the same as if I put my negative sign on the outside. So again, remember your negative sign can be in the numerator, it can be on the denominator, or it can be completely outside. These are all equivalent expressions. Okay, so please don't stress or worry over where to park your negative sign, because it just doesn't matter. It's all going to come out in the wash. Okay, so this becomes negative 1/2. So let's put 1's here in our exponents. So we have x to the 2 minus 1, and we have y to the 4 minus 1. So I'm going to erase this because it's in my way. I don't want to get super sloppy here. Okay, so 2 minus 1 is 1, so I have x to the first power. 4 minus 1 is 3, so I have y to the third power. And remember, you can write this even more simply by expressing it as just x instead of x to the first power. So that would be our final answer. Okay, so now we have 3x to the third power y to the fourth power divided by negative 12x y to the third power. So again, we can sort of rewrite it like a bunch of mini problems all together in a single problem. So we have 3 divided by negative 12. We have x to the third divided by x, or x to the first power. Then we have y to the fourth. Oops, how did that happen? Sorry about that. Then we have y to the fourth power divided by y to the third power. Okay, so again, remember, 3 over negative 12 is just a fraction that can and must be reduced. 3 goes into both the numerator and the denominator, and we get 1 over negative 4. Again, you can express that as negative 1 over 4. You can park your negative sign outside, you can park it in the numerator, or you can park it in the denominator. It does not matter. These are all equivalent expressions. Does not matter. Okay, so please don't spend a lot of time worrying or bothering over that. Okay, so then for our variables, we are applying the quotient rule, which tells us to subtract these exponents. So we're going to have 3 minus 1 and 4 minus 3. Okay, 3 minus 1 is 2, so we have x squared. 4 minus 3 is 1, so we have y to the first power. And then we can write this even more simply as negative 1/4 x squared y. So that's going to be our final answer. All right, let's do one more problem. So we have 4 divided by 12 times a to the fifth over a times b to the third divided by b squared. So 4/12, remember, it's just a fraction that we can reduce, right? We've learned how to do that. You can always go back and review or rewatch that video if you need to. So 4 divided by 4 is 1. 12 divided by 4 is 3. Okay, so we're going to have 1/3 here. Then we're going to apply the quotient rule. Remember, this is really a to the first power. So we have a to the 5 minus 1 power, and then we have b to the 3 minus 2 power. Well, 5 minus 1 is 4, and 3 minus 2 is 1. So we have 1/3 a to the fourth, b to the first power, or even more simply, we can write it as 1/3 a to the fourth b. And that's it. That's our final answer.